Microeconomic Theory Homework Help. To get more info, please contact us, +1 678 648 4277. Visit https://www.economicshomeworkhelper.com. Email info@economicshomeworkhelper.com. Microeconomic Theory. Problem 1. Show that the monotone likelihood ratio condition, f x/g x, increasing in x, where x is a real number, implies first-order stochastic dominance, f x g x, for all x. 2. Let equals 1 or 2 denote the state of nature in a two-state world. Let P0 equals PR equals 1. Let f p be an arbitrary distribution on the unit interval such that pf p dp equals p0. Show that f p can be construed as a distribution over posterior probabilities of p, stemming from an experiment with outcomes y, a prior probability p equals p0 and two likelihood functions p, y1 and p, y2. It may be easier to solve the problem if you assume that f p consists of two mass points so that the experiment will have only two relevant outcomes, say, yl and yh. 3. An agent has to decide between two actions, a 1 and a 2, uncertain of the prevailing state of nature S, which can be either S1 or S2. The agent's payoff as a function of the action and the state of nature is as follows. The prior probability of state S1 is P equals PR S1. Give a graphical representation of the agent's decision problem as a function of the probability of state S1. If P equals 0.4, what is the agent's optimal decision? Economicshomeworkhelper.com. B. Let the agent have access to a signal y before taking an action. Assume y has two possible outcomes with the following likelihoods. C. Show that, irrespectively of the prior, the information system 1 equals 1/2 and 2 equals 0 is preferred to the information system 1 equals 1/2 plus 1/2 and 2 equals, wherein are any numbers between 0 and 1. Hint, show that latter system is garbling of former. 4. An agent can work hard, E equals E, or be lazy, E equals L, where AL 0. There are two profit levels, X1 and X2, X1, X2. Hard work makes the high profit level more likely. Specifically, prob X equals X2 is FH if the agent works hard and FL/FH if the agent is lazy. The principal can only observe realized profits X. The principal is risk neutral and the agent is risk averse with preferences U, W, E. The utility function U is strictly concave and increasing. A. Assume that the principal's reservation utility is 0, that is, the principal has to be assured a non-negative profit. Show how to solve for the Pareto optimal action and incentive scheme S, 11 equals SI, I equals 1, 2, where SI represents the payment to the agent if the outcome is 11. B. Suppose that the agent is given the opportunity to choose a third action M with the features that prob X2 M equals 1/2 FH plus 1/2 FL and M 1/2 A plus 1/2 L. Can the principal implement M? C. Suppose that the second best solution in part A is such that it is optimal to implement A. Let the agent have access to the action M described above, but assume now that M 1/2 plus 1/2 L. Will the solution to part A stand once the agent is given access to M? Economicshomeworkhelper.com. 5. Consider the risk-sharing problem we saw in class. Show that the Pareto frontier is concave. In expected utility space, or, equivalently, that the feasible set of utility pairs is convex. Economicshomeworkhelper.com. Solution. Definition 1 MLRP G X is increasing in X. Definition 2 FOSD, f, x, less than or equal to g, x, x. Solution 2. You want to design an experiment that is a random variable y that takes value in 0, 1 for simplicity, and is characterized by the joint distribution p, theta, y, such that the distribution of posteriors generated by this experiment is given by f p. In the experiment, the posterior will be given by pr, theta 1, y, and the probability that this posterior arises is simply pr, y. In the statement, the probability that posterior p arises would be given by f p. Therefore, we'd like to take pr, theta 1 y equals p and pr, y equals f p for y equals p, which directly defines p, theta 1 y equals pf p, pr, theta 2 y equals 1 p, theta 2 y, sad face 1 p, f p. Does such a random variable exists? economicshomeworkhelper.com. Therefore, such an experiment exists. We can construct a random variable y such that the joint distribution of y theta is p theta y, since p is non-negative and sums up to 1, and the prior is given by pr, theta 1 equals integral p, theta 1 y, dy equals p0 as wanted. We can then define the likelihood functions using Bayes' rule, and we have pr, y theta 1 equals pr, theta 1 y, pr, y, slash pr, theta 1 equals pf p slash p0, and similarly for pr, y theta 2. You can then directly verify that the experiment defined by the outcome y, these likelihood functions and the prior p0 generate posteriors distributed according to f. Solution 3. 1. We are given u, a, s, therefore we can derive v, a, p. The upper envelope of v, a, p will be the v, p. It indicates the maximum expected utility that the agent can reach if faced with a probability of S1 equal top. economicshomeworkhelper.com. At p equals 0 point for the optimal decision is a 2 since. 2. We are given the likelihood matrix. economicshomeworkhelper.com. The probability of observing the two signals is, let's calculate the posterior probabilities. If lambda 1 equals lambda 2 equals, the information system has no value because the same signal y1 is as likely to appear in the two states of nature. Whenever lambda 1 equals lambda 2, the information system has no value. 1 if lambda 1 equals and lambda 2 equals 0, the likelihood matrix is the following. Posteriors in this case are, and probabilities of the two signals are economicshomeworkhelper.com. When observe y1. Therefore the optimal choice as a function of the signal is, hence, when observe y2. Therefore the optimal choice as a function of the signal is, economicshomeworkhelper.com. Hence, we can now calculate Vy as. We can now calculate the value of information as 3. We know that the Blackwell theorem gives general conditions under which one information system 1:1 is preferred to another. So we just have to prove that the information system lambda 1 equals alpha plus beta, lambda 2 equals beta 1 is a garbling of the information system lambda 1 equals, lambda 2 equals 0. 2. We have to find a Markov matrix M. economicshomeworkhelper.com. Such that the following relationship between the likelihood matrices holds. You can verify that such matrix M exists and is equal to the following. economicshomeworkhelper.com.